Hello, dear students. Hope you're fine. Today I'm going to talk about matter and its properties. Okay, chapter 1, section 2. Before we talk about the properties of matter, we must know what's matter. Okay, matter is anything that has mass and volume. So, what is, for example, door, window, animal, plants, anything that you see in your room, we can say it's matter because anything that takes up space and it has an amount, it has a mass, we say it's matter. Okay, which is not matter? Sound, dream, light, we say they are not matter because they don't have mass and volume. Here, volume means the amount of space or three-dimensional measurement. Mass is the measure of amount of matter. Basha? So if, for example, the sound has mass? No. Does it take up space? No. So we say sound is not matter. Okay, let's continue. Okay, basic building blocks of matter. Matter is made of what? What is the smallest unit of the matter? So scientists, they say the atom is the smallest unit or matter, or we can say the smallest unit of an element. We're going to talk about what's element that maintains the chemical identity of that element. Okay, so example, hydrogen, oxygen, these are examples for the atom, hydrogen atom, oxygen atom. So we have 118 elements in nature, and these elements, they're made of atoms. Okay, so atom is what? The smallest unit of an element. Okay, what is element? Element is a pure substance. When I say a pure substance, we can see by our naked eye it's not very small, but atom is very, very small. We can't see by our naked eye, but element is a pure substance we can see by our naked eye. So element made of only one kind of atom. Pasha? So when a group of one kind of atom together, they group together, we call them element. Look at this picture. Atoms, they can be different. There are 118 types of atoms in nature. So when a group of one kind of atom, Asha, they group together, we call them atom. Must be same kind of atom. Okay, so this is what? This is element. For example, hydrogen element, carbon element. Carbon and hydrogen, there are different elements because they are made of different types of atom. Okay, so what is compound? Compound also is a pure substance we can see by our naked eye. For example, a glass of water. A glass of water, the water you see is the compound. Is a substance, a pure substance. Okay, is made of what? Compound, they are made of two kinds of elements. For example, oxygen gas and hydrogen gas. When they combine together, they produce H2O. H2O is a compound, okay? So when two or more different kinds of element they combine, Basha, bonumuna, for example, oxygen element with hydrogen element, not hydrogen atom, because compound is big in number, in size. So H2O Pasha. So when these two elements, for example, when you say oxygen element, means millions, billions of what? Oxygen atoms, because we say atom, we say element. Oxygen element is made of a group of what? Oxygen, right? So hydrogen also, a group of hydrogen to produce H2O. Not okay. It produces H2O. Basha, H2O is what? Is a compound. Okay? You're gonna understand better when we talk about molecule. What is molecule? Is the smallest unit of element or compound that two or more atoms combine together chemically. Pasha. Generally, when two or more, same or different atoms, they bond together, Pasha, they produce what? A molecule. Molecule is made of atoms, Pasha. For example, O2 is a what? Is a molecule. Is made of two oxygens, right? Two oxygens. But these the oxygen atoms, two oxygen atoms, when they have bonded together, Basha, they what? They have produced O2. There's a covalent bond between them. Later we will going to talk about. So they have chemically bonded. So we call molecule. H2O, two hydrogen and one oxygen. Basha, one oxygen. They have bonded together to produce H2O molecule. Basha. So what's the difference between molecule and compound? So you say, teacher, here we have H2O and H2O here. Guys, compound is a pure substance like a glass of water. We can see by our naked eye. So look at this picture. Here, imagine this is H2O compound. H2O compound is made of a group of what? H2O molecule. Each one of these, this is oxygen, this is hydrogen, and the other one is hydrogen. Basha. So a group of H2O molecules, they what? Together, they form H2O compound that we can see. A glass of water is made of billions of what? H2O molecules. Basha? So because when oxygen, a group of oxygen means oxygen element with a group of hydrogen elements, they combine together, they produce a group of H2O molecules. A group of H2O molecules they're called what? H2O compound. Basha, it's same as elements. Basha, a group of one kind of atom together. So it says a molecule is the smallest unit of element or compound. For example, here for element, the smallest unit is what? Is atom, right? Atom. Basha. Molecule can be the smallest unit of element or compound. How? Guys, we have diatomic elements in nature. There are 7 diatomic elements. Their atoms, they are in pairs. What does it mean? There are two together. For example, hydrogen. We don't have a single hydrogen atom in nature. They are what? In pairs. So they have bonded together. So H2O is what? H2 is a molecule because 2 hydrogen atoms, they have bonded together. In nature, all the hydrogen atoms, they are in pairs. 2 they have bonded together. They're like that. You don't find a single hydrogen atom alone in nature. This is same for others: nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Basha, we call them diatomic molecules because their atoms, they are in pairs. Basha, they are diatomic. Okay, two atoms, they have bonded together. So these elements, their basic units, they are not atoms, they are what? Molecules. Okay, because their atoms, they are in pairs in nature. So a group of H2 molecules, it produce what? Hydrogen element. Okay, if you look at your molecules, look, molecules of elements. If you see molecules of element and molecules of compound, what's the difference between them? We know compounds, their basic units is what? Is molecule. For example, H2O compound is made of a billions, millions of what? H2O molecule. Basha, a group of H2O, same. Basha. These are molecules. Molecules of compounds, they are made of different atoms. Basha, look, different count. This is white, red, green, blue. Look, but molecules of elements, they are what? They are made of same kind. Okay, same kind of atoms. That's why it's going to be element. Okay, so this is the basic building blocks of matter. Okay, let's continue. Properties and change in matter. Chemists, they use properties of substance to what? First, to organize the difference between substances. Why properties are different, are important? Because we use them to what? To organize the difference between substances. Why stable salt NaCl is different than H2O? Because they have different properties, so we can organize the difference between them. Also to classify them, we know property of substance, we can classify them, okay, by their properties. Identify a noun substance. You have an unknown substance, you don't know what is it. So because we know the properties of material substances in nature, so by their property, for example, I give you a glass of water. How do you know it's water? So if it boils at 100 degrees Celsius, we know this is the water boils at 100 degrees Celsius. If it boils at 100 degrees Celsius and its density is 1 melting point, so these are properties. So if it boils at 100 degrees Celsius and its density is 1, we say it's water. Okay, so because we have many compounds, they are colorless. How we know it's water? By its properties. So another example, metal elements, they good conduct electricity. Okay, they conduct electricity well. So if you find something that good conduct to electricity, so we say it's metal. So that's why we can identify a noun substance by their properties. Okay. Properties are either extensive property or intensive property. So extensive properties, they depend on amount of matter. So matter change, the property changes. Look, property change with amount. For example, mass. If you increase the amount of something, its mass increase or decrease. If you decrease the amount, the mass what? Decreases. So volume of something, okay, the amount of carbon dioxide when you blow a balloon. So when you add more carbon dioxide, size increases. You increase the amount of CO2 air into the balloon, so the volume increases. So this property, which is volume, changes with what? Changes with amount, also amount of energy. intensive properties do not depend on amount of matter. For example, boiling point. Boiling point of water is what? Is 100 degrees Celsius, and it doesn't change. It's always 100 degrees Celsius. It doesn't change from one sample to another. If you increase, for example, the boiling point of one drop of water is 100, and if it's a glass, it's still 100. So you have increased the amount, but it's still same. Basha? Melting point also. Density of water is always 1. Okay? Doesn't change from one sample to another. So we say that density, melting point, boiling point, they are what? They are intensive properties. Okay? Let's continue. Physical properties and physical change. Physical property is a characteristic that can be measured without changing the identity of a substance. Okay. Physical properties, chemical properties, physical properties, physical change, chemical properties, chemical change. We're going to talk about that. Physical properties is a characteristic can be measured without changing the identity of the substance, or does not make any change in the substance. How? Melting point. You can measure the melting point of water without change the water. Color. I can measure the color of the wall without the wall changes, right? So you can measure the color of your eyes. So does any change happens to your eyes? No. The length, you can measure the length of your room without the room changes, without you change the, I don't know, this room, so nothing happens to your room. Volume, mass, you can measure the mass of something, but doesn't any change happens, doesn't need a substance be changed. Okay, so these are melting point, boiling point. These are what? Physical properties. Volume, length, because can be measured without what? Change the identity of substance. Means doesn't make any change in the substance when you measure. Okay, let's talk about physical change. It was physical property. Physical change is a change does not form a new substance. Basha? So when the change happens, something changes, but the change is not in its identity. For example, cutting. You can cut a paper, but nothing, for example, the paper is not going to be something else, not a new substance form, but you change the shape of the paper. Breaking, you can break a pencil, but still pencil, right? Both of sides, they are pencil. You have just changed the size and the shape. So tearing a paper, boiling water. I'm going to talk about a change of state. Boiling, melting, these are water changed to gas, but it's still water in gas state. Okay, for a change of state, let's talk about change of state. Is a physical change. All change of states, they are what? Physical change. Pasha, change of state is a physical change of a substance from one state to another. Okay, from one state to another. There are different types of change. Melting. Melting is a physical change. Solid change to liquid. Example, solid water to liquid water. Ice, when ice melts, when water is ice, when it's water in solid state, we call ice. Okay, so it's still water, but when it melts, also it's going to be liquid water. So this change of state, nothing new form. So this is physical change. Freezing. Liquid water changed to solid water, like ice. So at that time, water from liquid changed to solid. So at that time, nothing new form. It's still water, but in solid state. Basha, boiling is a change from liquid state to gas state, and a liquid water to water vapor. So when water changed to gas, changed to water vapor, guys, we call water in gas state water vapor. Okay. So these changes, vaporization, condensation, it's not written here, sublimation, these are also change of states. And all change of states, they are physical change, nothing new form, just you change the state. Okay? Okay, main states of matter. There are 4 states of matter: solid, liquid, gas, and plasma. 3 of them, they are very common. Okay? And they are called main states of matter: solid, liquid, gas. Let's talk about their property. I think you have learned in secondary school. Solids, they have definite volume and shape. Their shape and volume doesn't change. A pen is a solid, and its shape and volume doesn't change, right? So also a solid keeps the volume and shape. Basha, you put a pencil in a container, so the shape of the pencil doesn't change, right? Its volume doesn't increase or decrease. So solids, they keep their shape. Basha, why? Because particles of solid are very close to each other. Look, imagine these are particles of a pencil. Look, they are very close. There is less space between them. They're very, very close. What about liquids? Liquids, they have definite volume. Their volume doesn't change, but an indefinite shape. Their shapes change. You have water in a glass, so you can, in a bottle, so you can change the shape, right? But you can't change the volume. Volume is constant. I should take the shape of the container. So you have water in a bottle. You add it to a glass. Basha. So they change the shape, right? But still the same amounts, same volume. Okay. Particles in liquids, they're close actually, but not like solids. Look, there are space between the particles, but they're close, but not like solids. They can move. That's why shape of the liquids, they can be changed. Gas has indefinite shape and indefinite volume. Their shape and volume changes because particles, they are very far from each other. They can move easily. Basha. So gas, they take the shape of the container. Okay, you have gas in a cylinder, you add it to a big cylinder, so it directly takes the shape of that big cylinder. Basha. 4th state of matter, which is not very common. So plasma is a physical state of matter. Basha. In high temperature. Plasma forms in very high temperature. So atoms, they lose most of their electrons in very high temperature. So we can find plasma in stars, Basha, like sun, lightning, okay? And stars like the sun, outermost atmosphere, then other stars. So look, you add heat to a solid, it changes to a liquid. You add more heat, is going to be a gas. In gas state, if you add even more heat, the gas particles, they are going to be plasma. But at that time, electrons going to be lost out of the atom. Pasha, Look here, this is written here, natural gases. High temperature, look, the electron is going to be out of the atom. So atom is going to be cation. Cation is positive. Look, ions going to be formed during this process. Look, this is positive, shows the atom, and negative, this is electrons. So plasma can conduct electricity. Okay. Chemical property and chemical changes. Chemical property is different than physical property. Physical property, like we said, like color, you can measure the color of something without that thing changes. Okay, you can measure its property, which is color, mass. But here, chemical property is a property can be measured as the sample changes the chemical identity. You can measure the property of that substance, but the substance must be changed into a new substance. For example, ability to rust. Basha, I'm going to explain that. We have flammability, we have ability to rust, toxicity. These are examples. Ability to rust. We all know iron. Iron, does it have ability to be rust? We all know that rust, right? This is rust that covers the iron. So we want to know that the iron has ability to be rust. This is ability to be rust is a chemical property. So ability iron to rust is a chemical property, but we don't know that iron has ability to be rust until it reacts with oxygen and water. Then it produces rust. If it produces rust, we say that iron has ability to be rust. Pasha, and water. So look, the iron is going to be changed into a new substance, water and rust. Okay, it's going to be rust, produces rust. So rust, you can get back iron from the rust. New thing has formed. Basha, ability charcoal carbon to burn in air, ability paper to be burned in air. How we know? You burn it, you add heat. So fire. So when carbon react with oxygen in presence of heat, is going to be carbon dioxide. If carbon dioxide forms, means the carbon has ability to be burned. Basha, ability of charcoal carbon to be burned is what? It's called what? A chemical property. Basha, flammability. How easy something can be burned. How do you know? It must react. Okay? How we know something is toxic? It must react like with your body, with your skin. Then we know. Masha? Chemical change is easy. Is a change, something changes, but when the something changes, it produces something new. Is a change of one or more substances into different substances. Okay? Like burning charcoal, burning paper. Look, ability of charcoal to be burned is called chemical property. But burning, it represents a change. Burning a charcoal, burning a paper, digesting. These are what explain the process of changing. Basha, something changes. So when paper burns, it produces ash and carbon dioxide. So ash and carbon dioxide, these are two new substances. You can't get back the paper. I think you understand. That's easy. But chemical change, sometimes we call what? Chemical reaction. Basha? Chemical reaction. So chemical reaction, we can say, is a change of one or more substances into different substances. In a chemical change or in chemical reaction, we have reactant and product. Reactant, the substance that react in chemical change or chemical reaction. Product is the substance that has formed by chemical reaction. Okay, let's give an example. Carbon and oxygen, they react together to form carbon dioxide. Okay, so here these are what? Reactants, and the one that produces is called product, or we can say after the arrow, Basha, arrow goes from left to right. After the arrow, what I have is called product. Before, in the left side of the arrow, what I have, they are called what? We call reactants. Basha? Okay. Energy and change of matter. Guys, in each chemical change or physical change, energy is always involved. Without energy, does this reaction, does this change happens? No. So energy can be we can have energy in several different forms like heat, light. These are forms of energy. We have a law of conservation of energy, a law. It says energy cannot be created or destroyed in a change. When a paper burns, Basha, so a change happens, but the energy is not going to be released. Is not going to be created or destroyed. Basha. So, for example, solid, you need to add energies, then it's going to be liquid. You add more energy, it's going to be gas. But then if you change gas to liquid again, energy must be removed. Basha? It's like a circle. That it has gained, gas has gained energies, gas particles. But how they can be liquid again? They must lose that energy. But when they lose that energy, the energy is not going to be removed. Sorry, it's not going to be destroyed. Basha? So this is energy and change of matter. Classification of matter. Matter classified as pure substance or mixtures. Pure substance can be an element or a compound. Basha? So, classification of matter. Matter can be all, we can classify them to pure substance and mixture. Pure substance, elements and compounds. When you say an element means pure substance. Compound, they are all pure substances. Example, for carbon, for compound NaCl. NaCl compound, look, we can see by our naked eye, is a pure substance, as I said earlier. But the compound of NaCl is made of what? A group of NaCl molecules. Okay, both of them we represent by NaCl. We're not going to write millions of NaCl to represent NaCl compound. We just write NaCl that represents the compound and its molecules. Element of gold, Au. Also elements, they are what? Pure substances. Basha? Mixtures, they contain more than one substance, element or compound. A group of compounds, elements, they're what? They're called mixture, like salad, like sand and water. Salt and water. Look, salt is a compound, water is a compound. Two compounds together, they can form what? Mixtures. Or we can say pure substances, two pure substances, two or more pure substances, they form what? Mixtures. Okay. Mixture also, let's define it, is a blend, is a mixture of two or more kinds of matter. Each of them, they have different properties. For not two examples, two glasses of water, you mix them, you say this is mixture. No. Samples, they must be changed. It says each of them must have different properties, kinds of matter. Like salt and water can be. Salt and water, there are two compounds. You mix them, they are going to be mixture. So the parts of mixture, which is very important, they are mixed physically, not chemically. There is no bond between two substances. We have mixed them. So there's no bond between them. Like water and oil. two liquids, when we mix them, this is a mixture, but oil and water, they have different properties, but there's no bond between them. We can separate them easily. Salt and water, salt dissolves in water, right? When dissolves in water, is going to be like lost in water, we say like that, but actually it's not. We have salt in the water. When it dissolves, they have not bonded together. If you boil this salt water, you can get back the salt and the water. They have not reacted together. Nothing new has formed in. Okay? Orange juice also is a mixture. Pulp and juice. Okay, this pulp on the top and the juices. So these are mixtures. Okay? Mixture can be homogeneous and heterogeneous. Homogeneous, we call solution. If we say solution, we mean homogeneous mixture. Okay. Particles, okay, particles of the materials you have mixed them, they are equally distributed, like saltwater solution. Saltwater solution is a homogeneous mixture because salt dissolves in water and equally they are going to be distributed. Look, these are particles, how they are equally distributed. When something dissolves, Basha, in a liquid, in other substance, we say this is solution. Basha, heterogeneous mixtures, particles in these kinds of mixtures, they are not equally distributed. Clay and water mixture, look, have they equally mixed? No, these are, imagine the sand, and these are the particles of water. They are not equally distributed, but they are, both of them, they are mixtures. They have not like produced something new. Okay. Separation of matter. Matter can be separated. Basha, let's talk about separation of matter. Can be separated the matter physically? If yes, the answer is yes. We call them what? Mixtures. If no, we call what? Pure substances. Okay? So, for the mixtures, is the composition uniform? Yes, homogeneous. Means, are they equally distributed, the particles? Yes. So, we call homogeneous. No, heterogeneous mixtures. Granite, wood, blood, they're all heterogeneous mixtures. Guys, some mixtures, they are difficult to indicate it's homogeneous or heterogeneous, because if you look at it's outside, physically, if you see it, it's what it looks homogeneous, but actually heterogeneous. Like blood, components inside of the blood, they are not equally distributed, but it looks homogeneous. So sometimes it's difficult to indicate. So you are just responsible to the examples of the book. Basha? So let's talk about pure substances. Guys, pure substance cannot be decomposed by ordinary chemical means, by chemical methods. Yes. It's what? It's called compounds. No elements. No elements. So elements, they cannot be decomposed by chemical method or physical method. But compounds, they can be separated, but not by physical method. Only by chemical means, like chemical methods. Like water, you can decompose water. We're going to talk about by electrolysis. Sodium chloride also by the same method. Sucrose. Sucrose also, we can separate it by heat. Or I'm going to explain that one. Methods of separating mixture. Mixtures, they can be separated. Okay? We have different methods to separate mixtures. Filtration, centrifugation, paper chromatography, vaporization, decantation. So filtration, we use it for heterogeneous mixtures like barium chromate. When you mix barium chromate with water, barium chromate is not going to dissolve in water. It's a heterogeneous mixture. How I'm going to separate it? I use a filtration method. You need a funnel, you need a filter paper. Filter paper is special paper. There are very small holes in it that lets the barium chromate pass through the paper, and it lets the water pass through the paper, and the barium chromate is going to be left on the top of the paper, is going to be a residue. Okay, so we can separate it like that. Centrifugation also is a method to separate solid liquid mixture like blood. So according to you are going to use a centrifugation. Look, I think let me show you. Do you see this? Okay, these are, look, this is centrifuge. Okay, you are going to put, for example, like blood. So you can put blood is an example for heterogeneous mixture that we can separate it by centrifugation. You're going to put different samples in that centrifuge, and by spinning very fast, and according to gravity, those they are heavier is going to be at the bottom of the test tube. Look, okay, so that's nice. I'm going to, okay, paper chromatography. Also, this is a method to separate dyes, pigments. Okay, so you need a paper. This is a paper. You're going to add some water until here, Basha. So you put some drops of dyes, pigments. They're made of different colors. So we're going to separate it into different colors, Basha. Those they are faster, they're going to travel faster. Those they react faster with water, they are going to travel faster. Look, then we can separate the pigments into different colors. Okay, so vaporization is very easy. Is used for homogeneous mixtures. Sorry, paper chromatography also we use for homogeneous mixtures. Okay, for example, you boil, we have salt water, you boil the salt water, salt left behind, and water is going to be gas, because the one that has lower boiling point is going to boil first, and the salt, it has high boiling point, means doesn't boil at very low temperatures, it needs very high temperature. Okay, so this vapor decantation is also for heterogeneous mixtures when solids and liquids there are being two phases, and you see all these solid particles there at the bottom, so you can just pour carefully, and the solid is going to be left behind. Okay, pure substances are elements or compounds. All pure substances are homogeneous, Basha. All water is a homogeneous. All H2O molecules, they are equally distributed, like pure substances. Also elements, like you have seen iron. You see the all parts of the iron metal, they are what? They are equally distributed. So all pure substances are homogeneous. Pure substances, they have fixed composition. I'm gonna explain here. So their composition is always same. Elements cannot be decomposed, right? We said just compounds. Compounds, they can be decomposed into simpler compound or element by chemical means, by chemical method. We said that. So mixture is different from a pure substance in the following ways. How? All samples of a pure substance have the same characteristic physical and chemical properties. For example, you have two glasses of water, two samples. Both of them, they have same boiling point, because all these samples of pure substance are same. They have same physical chemical properties. Okay? But mixtures, no. You have, for example, you have different samples. different. You are going to prepare sand water mixture. So both of them, if you prepare two um, samples, they're going to be different in what? In components, in physical and chemical properties. Okay, unlike mixtures, all samples of pure substance have same makeup. Look guys, H2O as a sample of pure substance, always by mass, 11.2% is mass of hydrogen. You have a glass of water, imagine 11.2%, the mass of that water is the mass of hydrogen, and 88.8 is the mass of oxygen by mass. Doesn't change. So for like H2O to H2A for molecule, by mass 11.2 is the mass of hydrogen, and 88.8 is the mass of oxygen. Doesn't change, but mixtures changes. Okay, it changes from one sample to another. Okay, for example, salt water solution is a mixture. If you add more salt, the components changes, right? Difference between pure substance and mixture. I have made that for you to understand. Pure substance consists of single type of substance, but mixtures consist of two or more kinds of substance. Pure substance, just compound, they can be separated by only by chemical method. Mixtures can be separated into its component by physical methods, because there is no bond between them, physically can be separated. So pure substance, it has its own different properties. It's known, right? But mixtures, they show the properties of components. Components change, the property changes. But in water, you add more and more water, increase the amount of water, but its property doesn't change. It has different property. All samples of pure substance are homogeneous, but mixtures can be homogeneous or heterogeneous. Okay? Decomposing of compounds, guys. Compounds, they can be separated, but elements not. We're going to talk about two chemical methods, electrolysis and heat, to decompose compounds. Example, water. Water can be separated into hydrogen and oxygen through chemical reaction called electrolysis. By presence of electrolysis, H2O compound can be decomposed into hydrogen and oxygen gas. Look at here, this is an example. You're going to pass the current through the water. This is water, look, water molecule H2O, but when the current passes through the water, water is going to be decomposed into oxygen and hydrogen gas. Basha. Another method, sucrose, can be decomposed by heat. Okay, you heat it. Look, an example, you're going to decompose into carbon and oxygen, carbon and water, carbon dioxide also can be. When sucrose is heated to a high temperature, it breaks down completely into carbon and water. This is sucrose and oxygen. Guys, when you burn something, there must be oxygen. And there must be oxygen. Without oxygen, can you burn a paper if there's no air, if there's no oxygen? No, you can't burn. So when you burn something, you need oxygen and heat. So when you heat a sucrose, it's going to be carbon dioxide, carbon also you can say, and water. Pasha? Here also we have. So laboratory chemical and purity. And guys, the materials, the compounds that we use in lab must be pure. Like for example, the water you drink is not pure water because it's not only H2O molecules. So all chemicals have some impurities, like, so for example, in water you drink contains some ions like sodium, so okay, calcium. So these are called impurities. So all chemicals have some impurity. If you try to get a substance that doesn't contain any impurity, only that substance, it's a little bit impossible. We have a little bit impurity, but impurities, they affect the result of reaction when you react two substances together, because they contain some impurities. The result is not going to be accurate. Basha? So, but chemicals in laboratory generally treat as if they are pure. So we try to use pure substances. Okay? This must be clean, we can say. So this is section review. You can look the answers. Okay, you have it. Thank you very much. Later we'll talk about chapter 1, section 3. Thank you for listening and watching. See you next time. Bye.